where does IPFS kind of fall short?
You have no guarantee that your data stays available on IPFS.
They were speaking about storage buckets. What does that mean?
That's the feel of trust.
That's insane.
The launch team wishes you good luck and Godspeed.
Space Monkeys blasting off with Ludwig Trappe. He's the BD lead of Crust Network. Lud, welcome to the show. Jesus Crust himself.
Thank you, Jay. Pleasure to be here.
I've been hearing a lot about you guys lately. It seems like you guys are building a lot of momentum around your project, both inside the ecosystem and out. But maybe you could start by telling us an overview of what storage even looks like in Web3 and how it's different than the storage we're used to in Web2.
Sure. As you probably know, Crust Network is a decentralized storage and hosting service provider.
Yep.
And in Web2, we are used to using centralized big companies like AWS, like Google Cloud, who basically store our data, who control our data, who guarantee our data. And when we talk about Web3, that's something we try to avoid, because the biggest differentiator between Web2 and Web3 is actually the part of the ownership. And when we're looking at the most fundamental layer, which is the physical infrastructure layer, then we have to admit that we are quite far away from that yet. Most of our Web3 data currently is still in possession of like those big three cloud providers everybody knows.
Yeah.
And they basically are in control of our data. They can hold our data hostage. They can censor our data if they don't really like what we have to say or what we want to do with our data. It's not permissionless at all.
Yeah.
And on the other hand, they don't just hold our data, but they also use our data to monetize it for their benefits and their profits. And that's something we don't want to have in Web3, because the power is supposed to go to the user itself, to the content creator itself. And those currently available centralized cloud services, where most of the services and solutions run on currently, don't really do that. And every kind of service or solution in Web3 has some kind of demand for storage or hosting services, and it's most of them still go to the, let's say, established Web2 providers. But we are here to change that.
Okay, you guys are built on top of IPFS, the Interplanetary File System. Can you quickly give us a breakdown of how that works, and we'll talk about how you guys are leveraging it? Sure.
IPFS is a beautiful thing. So it's an immutable way of storing content, of storing files. What they use, or what makes it special, is that instead of addressing the location of where the content is stored, it addresses the content itself. So it doesn't matter where the content is stored on, as long as it's available. So for example, I could address you by saying, hey, this is Jay, or I could say, hey, he is sitting on chair number 5A. And on chair 5A, it's J. But IPFS says, no, I address J immediately, directly, instead of the chair he's sitting on.
Oh.
That's like the difference between content-based addressing and location-based addressing. And that's why in IPFS, their URLs are basically CIDs, content IDs, it's called.
Okay,
and
thank you.
And those content IDs are unique and immutable. So, for example, when you go to Amazon and you upload something to a specific location, then you have the path, the directory to the location, but the content behind this location still could change. And you couldn't track if this content changed, because it's not a unique way of addressing it. You're addressing the place, but you have no influence about what's happening in this place itself. So the data could change, but your URL still points to the thing. For example, an NFT. When you look at an NFT contract, you have an URL somewhere that points to the metadata, to the visual of the NFT, to the PNG, to whatever. But if this link breaks, then all your link is routing to is a very expensive 404 error page.
Sure, yeah.
And,
okay, yeah.
and this can't happen with IPFS. Anyways, IPFS is not incentivized. So it's an open network, almost like a torrent kind of network system, where people can provide their storage resources, and other people, on the other hand, can use this resources. But again, this is not incentivized. There are no rewards for it. It's all on free will, which means you have no guarantee that your data stays available on IPFS.
Yeah.
And
Interesting.
that's basically where Crust Network comes in.
Mm-hmm.
We provide a guarantee via a decentralized, trustless protocol to keep your data on IPFS, and we do that by pinning this data to our own nodes. We have a physical infrastructure of, at the moment, I think, 1,450 nodes, providing an overall storage capacity of 600,000 terabytes, so quite a lot.
Wow.
I think 22,000 of that is used currently, so utilization is not too high yet when we look at the ratio of total capacity to use capacity.
Sure.
But when we compare it to ARI, for example, which is another storage-related project in Web3,
Yeah.
their entire Arweave net contains, I think, 115 terabyte only.
Oh,
Yeah.
wow. Okay.
So, and when we put this 115 in comparison to this the 22,000, then like we can say it's already quite big.
That's incredible.
Yeah.
Obviously, storing in big data centers also probably has its advantages. Where does IPFS kind of fall short?
A lot of people would say it's the performance.
Okay.
Because usually IPFS is not as performant as traditional Web2 data centers.
This means like the speed of retrieval.
Exactly. Upload time, speed of retrieval, and so on.
Okay.
That is a lot of, this can result in a lot of issues, especially when you need kind of data storage for hot storage use cases,
Sure.
where you need fast retrievals, fast uploads, where you retrieve it very often. So not just the classical archiving cold storage use case. But Crust Network has a solution for that. And this is, on the one hand, we are very efficient with our protocol stack. So our data sealing process, for example, is 60 times faster of what Filecoin offers. And on the other hand, we follow a multi-replica approach, which means when you upload your data to Crust Network, you don't just get one replication on one node, you get multiple replications throughout the entire network.
Oh.
And on average, per file upload, you get around 33 replicas all over the world, which also means this will be able to improve performance. And I can tell you why. First of all, IPFS is able to retrieve data from multiple endpoints at the same time. So the more endpoints you have, the more nodes that store your data where you can retrieve it from, the quicker you can download the pieces, retrieve it.
Okay.
And on the other hand, obviously it makes a difference when you're based in the US and the only node hosting your file is in Shanghai. Then you have a really high latency.
Yeah.
With more distributions all over the globe, the chances that like a node is close to you is way higher than like if you only would be one kind of replica.
That's fascinating. But does this pump the numbers of the amount of data you have stored? Like you said, 22,000 terabytes, right?
Yeah.
So does this 33x replication, does that pump those numbers up, kind of?
Yes, it does indeed, but I was talking about unique files earlier.
Oh, wow. Fascinating. Okay. And also this storage is cheaper than Web2 options. Is that right?
Oh, yeah, it is. It is. Currently, it's, I would almost say too cheap because it's, I think, $0.001 per gigabyte and year. But this is also because currently it's still incentivized via blockchain emissions and so on to make it profitable for the miner side.
Okay.
Because obviously when you look at the miner side, there are some hard costs, like an HDD for storage capacity. I think when you buy a 20 terabyte business grade HDD, it's around $400, $500.
Yeah.
So, and they have like a lifetime of around 3 to 5 years. So it's quite easy to calculate what's the cost for providing specific resources and the electricity that come with it and so on. So even if we take all of this into account, and even if we give those miners an additional margin on top of their costs, we still would be 60, 70% cheaper than Web2 solutions currently.
That's wild.
Yeah.
So is there any specialized hardware needed, or is it off-the-shelf HDDs?
The HDDs is not the issue, so you can pretty much take anything.
Okay.
What we do, what is needed for our protocol, is a CPU that can do TEE. TEE is Trusted Execution Environment. So it's like a secure enclaved environment in your local CPU where you can guarantee the integrity of specific processes and so on that not even the node operators themselves can access and tamper with the data and so on.
Yeah.
So that this is basically the only kind of requirement at the moment.
Okay.
Basically, an iPhone even has TEE. So we didn't write the script yet, but you theoretically you could provide your storage capacities from your iPhone because it has this TEE functionality.
Right. And which TEs do you guys support so far?
I know all the Intel iCore 5, 7, 9. They're all working.
Okay.
And some Xeon. So Intel is very big on TEE.
Yep.
But in the future, we're also going to move towards zero knowledge technology, which makes TE not redundant, but we're going to go towards a hybrid kind of solution. Yeah.
Fantastic.
Because both kind of things have their advantages and disadvantages, and with a hybrid solution, there will be the best out of both worlds.
That's amazing. So over a month ago, we shared our interview with Apollon with the audience, and they were speaking about integrating with you guys for their multi-chain apps. They were speaking about storage buckets. Mm-hmm. What does that mean? And what are they talking about?
Yeah, that's a good point. They're talking about our latest release. So far, we did our protocol stack with our decentralized physical infrastructure, our incentive and service layer for IPFS, which we see as our infrastructure as a service vertical kind of product.
Yeah.
But we also want to drive adoption, to drive usage. And we want to do that by building a commercial solution on top of our infrastructure as a service. And our very first product release of this will be Web3 storage buckets, which will be a brand new concept. We're going to redefine the way how you think about storage capacities in Web3. And this will come as an NFT. So basically, when you think about a storage capacity, you can think about an NFT. You own it in your wallet like any other NFT. You can trade it like any other NFT. You can transfer it between accounts, including all rights and of ownerships and benefits. And all of this is also provable on chain, like with any other NFT.
Okay.
And this is a very revolutionary thing because so far storage services have been based on an order-based system, where for every kind of file upload you want to make, you have to create an order on chain, a transaction on chain to execute this order. This is not what Web2 developers are used to work with. Also, they're more used because to work with storage capacities, and also because the price is an on-chain price, it's very fluctuative.
Sure, yeah.
So today you want to upload a data, it might be 1 cent. Tomorrow you want to upload data, it might be 3 cents. And this 300% fluctuation, no developer who's working with lots of volume of data wants to have this fluctuation in his price. So he wants to have like a fixed price that's forecastable and not depending on network activity or other metrics that define it.
Yeah.
And with this kind of Web3 storage bucket, we will be able to distribute storage capacities for like a fixed price, and developers can use that like their Amazon storage bucket. And as already said, they can go to our minting contract, can mint this NFT. It's totally customizable. So you can say I want a 10 gigabyte bucket because that's totally enough for me. But you also can say I want a 1 terabyte bucket. And you mint it, you pay it via cryptocurrency. We have different payment options. And then you hold it in your wallet, wherever you want it, in your MetaMask, and can access your storage capacity with the authenticator token in your wallet.
Wow, that's interesting. And associated with this NFT will be like how much storage is left and who has the rights to access it? Like what sort of...
Yeah, let's say you are going to our dApp, you mint a 10 terabyte or 10 gigabyte storage bucket.
Sure.
And you upload your 10K NFT collection to it because you're an NFT creator. Then like you, for example, can see, now 8 megabyte out of this 10 megabyte is already filled.
Interesting.
And then you can basically fill it to the rest, or you can say, now I need a new one. I mint another bucket for my next project or whatever I need it for.
Wow.
And this will solve a very critical issue in Web3, which is the issue of ownership.
Yeah.
Because for the very first time, this will give users and builders the opportunity to really own their storage capacities and to pass it on to the users of their platform.
Right.
When we think about current platforms, then like NFT marketplaces or decentralized social platforms, then who are we uploading our data to? It's the platform operator itself. And we don't know where or what service the platform operator is using again. So he might be using AWS, but he also might be using IPFS, which would be already better. But still, in the end, he still has to guarantee the availability on IPFS somehow. And he's doing that usually by either paying a centralized service again, like Pinata, or by running their own local nodes, again, centralized. And if this service should go down, this platform should go down for any reason, then this NFT will be gone. We have seen it with FTX, by the way. all NFTs ever minted through their user interface were gone after FTX went down, because due to their bankruptcy, they stopped paying the storage service, and all NFT data was vanished. So this can't happen on Crust Network.
Wow.
Because all data will be guaranteed, especially within those buckets.
So what happens if I mint a 10 gigabyte bucket, I upload my NFT collection to it, and then I give the NFT to somebody else? Now they own all the data stored in that bucket?
Well, if you transfer the bucket to them,
Yeah.
yes, you can basically transfer the ownership of your entire art collection if you wanted to.
Really? And then they could delete it? I'm just wondering, like, what would happen if, somebody got into my wallet or something? Because there's a self-custody thing as well,
Yeah,
right?
yeah.
Which has its, drawbacks.
Yeah, obviously
and
it says like
advantages,
his drawbacks, like
Interesting though. Yeah, I love that. Okay, and you were talking about passing on ownership to maybe the people who bought into the collection. How does that work? Do you like fractionalize the NFT, or is it just?
You could offer it. You could offer this entire bucket on OpenSea. Actually, you already can do that today. When you look at OpenSea and you search Web3 buckets, you find our buckets.
Whoa.
You don't know what's in those buckets because it doesn't tell you the data behind it.
Interesting.
But you can see those buckets, and you see who owns it, which account owns it, like it was a normal NFT on OpenSea.
Wow.
Yeah.
Fascinating. Okay, good stuff. So Applon has integrated or is integrating these buckets?
Yeah, they're planning to. Applon, really good friends of ours. Cheers, guys.
Yeah, cheers. Who else are you guys working with?
We're working with quite a lot of people, especially within the Polkadot Kusama ecosystem. So we're working with Subsocial, we're working with Robonomics, it's still machine data. But we don't only work with Polkadot and Kusama related projects, but also with other ecosystems. So we see ourselves as an omni-chain protocol for storage services in Web3. Mm-hmm. And we provide a lot of different cross-chain services. For example, we provide cross-chain services to Ethereum. We provide cross-chain services to Arbitrum, to Aptos, to Polygon, Solana. And we do that via different ways. For example, when we're talking about smart contract-based ecosystems, we deploy a native smart contract on their side, which can be called from their builders, their users, developers, and so on. They can pay in their native currency to use our storage services.
Really?
Yeah.
Okay, so you don't need crew on every.
No, you don't need our own token to access our resources.
Yeah.
And it's totally native for those builders of those specific ecosystems. And in fact, we also are represented in the official documentation of Ethereum, Polygon, Near, and many more as recommended storage partner.
That's insane.
And we also have like some really popular user that use our technology for different kind of use cases. For example, Uniswap and Avi using Crust Network to host their decentralized application in a totally decentralized way.
Right.
For example, when you visit Avi and you say launch app, then you get a pop-up that says we're going to redirect you to our decentralized IPFS version of our application.
And people can choose it?
I think it's mandatory. I think they made it mandatory.
Wow.
I think Uniswap doesn't even tell you. They call the IPFS page directly.
Yeah.
And when you look in their GitHub, you can see they use Crust Network to actually pin their front end to IPFS. And I think both of them enjoy around 70, 80 replicas on our network.
That's amazing, yeah.
And I guess you didn't have any performance issues with Uniswap or Avi. So
No, I haven't.
Yeah. That's the feel of Crust.
That's insane. And as head of BD, what do your days look like? Like, how do you reach out to projects? How do you let them know what you guys are doing?
I do a lot of, if you want to say cold calling. Like,
Okay.
Not traditional calling, like, we're on Web3. It all happens over Telegram,
DMing,
Discord, etc. But I personally, I come from a Web2 cloud computing environment. So I did consulting and software as a service before. So I try to see what's the perfect client for us. So those probably is a client who has like high demand for data, who has an advantage of it when it's decentralized, and where the use case makes sense. And so I'm looking for different projects. Obviously, different projects, NFT marketplaces, DeFi applications. When we're talking about hosting of decentralized applications, all of those are potential clients for us.
Yeah.
And then we approach them, check what value we can offer. They do analysis if they already use some kind of IPFS where we can start from. So that makes it easier when they already use IPFS in some way.
Right.
And we help them to basically get their data on a decentralized network. But we also have a lot of people that come to us because they heard we are doing these kind of services, because we had some good references in the past and so on. And we believe that the decentralization of data on the most fundamental level, the physical infrastructure, is getting more awareness.
Right.
Centralized services fail more and more, and especially because of the ownership issue we have with traditional cloud providers and storage providers. All of this hinders us and blocks us from achieving the vision of Web3, which we really want, where the power is with the user, and the user is in charge and in ownership of his data and content.
Yeah, we had Hoon Kim on Sama Nights a couple weeks ago, and I know that he's hosting his game on your platform. Are you thinking about gaming at all? Do you see a big audience and user base there?
Yeah, sure. Let's go back to this buckets, for example. Again, you can have, for example, your account on a gaming platform, and to this account you assign your bucket, which you own with this account. So every kind of avatar, skin, or item you could receive in the game,
right.
you could own in your own bucket, and not the platform operator basically owns it and you just access it, you know?
Right.
So when you have it in your bucket, you basically could sell your bucket, you could sell your avatar down the line to other players, offer it on OpenSea and much more. So this will provide you a lot of different opportunities for new kind of use cases and scenarios.
Do you think down the line you guys have the technical prowess to make traditional data center-based storage solutions irrelevant, or do you think there'll always be a use case for both?
I think it will take a little bit of time.
Sure.
I've seen the development back then from on-premise storage and on-premise solutions to cloud solutions. I basically was 2014 when we started with our software as a service company back then, and it was a really hard time to move companies from on-premise local storage to the cloud, because they were so skeptical about it, and we don't know who has our data, and it really took years, almost a decade. And nowadays, I think over 80% of all business applications run via the cloud.
Yeah.
So for me, it's just the next step in the evolution.
Right.
From on-premise to public cloud to decentralized cloud, basically.
Yeah.
Because on-premise, the user was in full control over his data. He had the full control over his data because it was on his local server, wherever, which he operated, which he managed, and he only was the one who has access to it.
Yeah.
With the cloud, we had the usability factor, access your data anywhere from any time. But the issue was, you weren't the only one in control of it again.
Yeah.
But with decentralized storage, we can combine the advantages of both. We can combine the ownership of the on-premise storage with the usability and comfortableness of the cloud storage.
Right.
And this basically is decentralized storage. So for me, it's just the next step in evolution.
Yep.
And just a question of how long it's going to take, not if it's going to happen.
Amazing.
Yeah.
Well, Jesus Crust. Thank you very much for coming on the show. I learned so much about storage, and it's I appreciate the Crust project even more. And I want to congratulate you on the great job you're doing, obviously connecting Crust to projects inside the ecosystem and without. And so congratulations on that, and thanks very much for coming on the show.
Thank you, Jay. Thanks for your time, for interviewing us, for giving us a chance to present our project and the vision we are going for.
Amazing. Talk to you soon, bro.
Thank you, buddy.